Hey there! Today I'm gonna show you how you can use a reranking model to improve your RAG architecture. So first I wanna say that the standard RAG pipeline does a decent job actually ingesting data and retrieving relevant information and then feeding the information into a large language model to generate response. But it has some limitations and we all know that. And it lacks the power to deal with complex problems. That's why we need to use advanced techniques in our RAG architecture to deal with those complex problems, and reranking is one of them. So what happens is first we're gonna have a initial retrieval that is going to basically be a query that we have a instruction. We have a instruction that's going to be converted into a embedding. There's going to be basically a vector of numbers, and we use the embeddings to search or query in our vector store to retrieve the documents where we have the context that are the most similar to the instruction that we just sent to the query. So here in this draw we're gonna have retrieved the document 1, 2, 3, and 4, and that's gonna be our most relevant documents in this first search. What a reranking model is gonna do is basically take a second look your retrieval document, so it could optimize the position using a relevance score that's going to be attached to each document. So here we have the document re-ranked. So here you can see that we're gonna have a document 1 with the relevance score, and also the document 2, 3, and 4, all of them with the relevance score that's going to be attributed by the reranking model. So that's good, and that's like take a closer look at the documents that was retrieved by the vector store and consider things like context, intent, and nuanced relationships. So the idea here is to improve the RAG architecture by introducing this intermediary step in order to rearrange the documents that are being retrieved by the retrieval component, and ideally we're gonna have the most relevant documents at the top and the less relevant documents at the bottom. So here we're gonna have this as our most relevant document right here, and here our less relevant document. So what we can do is to feed this as a context to the large language model or to our AI as a sorted context where we have the most relevant document at the top. But we can also do a cutting right here, so we can refine our context by eliminating the less relevant documents, so we could achieve a better accuracy in our response. So this is what is being used right now in this re-ranking approach. So the idea is to retrieve a bunch of documents from the vector store, and then we're gonna re-rank and select the most relevant documents out of this bunch of documents. So we are not gonna use all of the documents that the vector store is going to retrieve to us. So we're gonna use only the most relevant information to our instruction or our query. And with that, your system will return results that are not just related to the instruction, but are spot on relevant. So, I mean, it's of course is going to improve the accuracy of our architecture, and that's why we do it. And more accurate results mean happier clients or happier users who find what they need faster. And by filtering out the fluff, users can focus on what really matters. So that's why reranking plays a nice role with advanced AI systems, supercharging things like RAG models or RAG architectures. But of course, it has its own disadvantages, and I mean, rerank comes with its own set of challenges, and I think the most famous one is the computational cost, because it requires more sophisticated analysis, and sophisticated analysis means more computational resource. So that's the top one disadvantages of this approach. And also we need to find the sweet spot between speed and accuracy, and that can be tricky, because if we try to increase the accuracy as most as we can, our model, our re-ranking model, can take some time to calculate the most relevant documents and sort them in an order that makes sense. So that's one issue. And also we have the domain adaptation. And what I mean by that is because one size doesn't fit all. So you might need to tweak your re-ranking for specific domains that you were working with. So yeah, that's one of the challenges. But in my opinion, I think that doesn't add up to the amount of benefits that having a re-ranking model in your RAG can bring. So my suggestion is try to implement or use a re-rank approach inside your architecture to have more accurate results and improve your systems overall. I think re-rank plays a major role on that. Of course, you have some other techniques like prompt optimization, and it goes on and on, but I think that apply re-ranking here will solve most of your problems, and you're gonna have a RAG architecture that's going to be more accurate. And if you have any questions about how to implement a re-rank step in your RAG architecture, please let me know and we can discuss about it.